To lab number 5. Yeah, lab number 5. We're like moving right through this lab manual, aren't we? So lab number 5 is going to be more histology. So we are looking at more tissues. In labs 3 and 4, we looked at epithelial tissue. In labs 5 and 6, we are going to look at connective tissue. Connective tissue is pretty amazing. We're going to see a whole lot of different structures that do a lot of different important things. One of the things that's neat about connective tissue is just the diversity of structures we're going to see. We're going to see things that look very different from one another. But connective tissue, the different connective tissues are tied together. They come from the same place embryonically. So they have this common embryonic origin, but then as we develop, they do change and become vastly different with different jobs. But we're going to see there are some common things to them. So even though they might look rather different at times, there's going to be some commonalities. Now, today, we are looking at 4 types of connective tissue. That's it. 4 types. That's all. First one we're going to do is this type of connective tissue called areolar connective tissue. So everything you see here in this picture is areolar connective tissue. The word areolar has this connotation of open space, so there is often a good deal of space within this tissue. Now, as we look, the very first thing I want you to notice is the cells, okay? Now, you guys are good at identifying cells at this point, I hope. You know to identify a cell by looking for that nucleus. So I see a good number of nuclei here. But notice how the cells are not tightly packed. If this were epithelial tissue, there would be so many more nuclei and thus so many more cells. And in fact, this is one of the characteristic features of connective tissue. It doesn't have that many cells. The amount of cells are far dominated by something else, which is often abbreviated the ECM. ECM stands for extracellular matrix. Connective tissues, they're not that cellular. They are dominated by this stuff called extracellular matrix. Extracellular matrix is going to primarily consist of 2 things. There are going to be fibers and a liquid called ground substance. So fibers and a liquid called ground substance. That's what makes up the extracellular matrix. Now, extracellular, what does that mean? Outside of the cell. Matrix is just a better way of saying stuff, right? You're not going to say extracellular stuff. Let's say extracellular matrix. So this is a hugely important characteristic of connective tissues. Most connective tissues are dominated not by cells, but instead by cell products. And the 2 cell products are fibers and extracellular matrix. Fibers and ground substance. Got a little ahead of myself there. Fibers and ground substance. And those 2 things, fibers plus ground substance, equals extracellular matrix. All right. We snuck a little connective tissue background in there, didn't we? So this is a type of connective tissue. It is called areolar connective tissue. I do see nuclei of cells, but not nearly as many as I would see in epithelial tissue. Because connective tissues are typically dominated by extracellular matrix. Now, the most common cell I do see here, the green arrow is on the nucleus of one. This guy here, here's another one right here, another one right here. These guys are cells called fibroblasts. All right, so this is a fibroblast right here. Fibro means fiber, blast means sprout. I like to think of blast as indicating the process, production. So these cells are all about fiber production. They are the fiber makers. So these fibroblasts are fiber makers. And we can readily see the fibers here. I can see two types of fibers in this picture. One is really easy to see. The other is a little bit more cloudy, a little bit harder to see. Let's start with the easier one. This skinny line right here with the blue arrow on it, that is an elastic fiber. In fact, there are elastic fibers crisscrossing all throughout. All these skinny purple-ish lines are elastic fibers. Elastic fibers let the tissue stretch and recoil. Sometimes people think the word elastic just means stretch, but no, you got to stretch and snap back. So elastic fibers are like a rubber band. They stretch and they snap back. They're not like a piece of chewing gum you've been working on for a while where you can stretch it, but then you let go and it doesn't snap back. Now, these elastic fibers are not the only type of fiber here. We do see another type of fiber, and it's these thick pinkish lines. Like there's one right there, here's one right here, one over here, there's one over here. These thick pinkish lines are collagen fibers. Collagen is really, really strong. So they have what's called high tensile strength. That means they're able to resist tension. That means you can pull on them and they're not likely to break. If you like pull on the fibers, like imagine grabbing a string and pulling on each end and trying to rip it apart that way. Not going to happen. Collagen fibers are like this. So these are two really important characteristics. Areolar connective tissue, because of the presence of collagen, has tensile strength, and because of the presence of elastic fibers, has resiliency, the ability to change shape, to be deformed, and then to recoil, to achieve that shape again. And this is important, okay? You find areolar tissue all over your body, by the way. You find it underneath your epidermis, so it's in the papillary dermis of your skin. You find it in pretty much every single organ. It's kind of like the bubble wrap of your body. Okay, with that, I think we are done both our kind of intro to connective tissue and our look at our first connective tissue type, which is areolar. All right, fantastic. So here I have another view of areolar tissue. And I have another view because I want to show you something new. Now let's point out some of the things we already have learned about. I see a nucleus of a cell right here. See another one up here, a couple more over here, one down here and here, two more over here. All those guys are fibroblasts, which, as you recall, are fiber makers. They're making elastic fibers and they're making collagen. We are also able to see those fibers here. Here is a beautiful elastic fiber right there. Look at that guy. That is an elastic fiber. Here's another one right here, another one over here, one right here, one right here. There are a lot. Now, not only can I see elastic fibers, I can really nicely see some collagen fibers. In fact, I kind of like the collagen fibers on this picture better than on the previous one. Here's a nice collagen fiber up in the top right-hand corner. Here's one kind of in the lower left. Now, what's awesome about this picture is I see another cell that I often find in areolar connective tissue. And that cell is called a mast cell. This guy right here is a mast cell. I see his nucleus right there, and I also see all his granules. In fact, he's kind of like has lost some granules as they made the slide here. All these little dots are granules, little bags in the cell that are filled with some inflammatory chemicals. And those two inflammatory chemicals are histamine and heparin. They cause inflammation. Now, what's your view on inflammation? Is it a good thing or a bad thing? Well, I'm going to tell you, 99% of the time, inflammation is a good thing. It is the very first step you take anytime any sort of tissue gets injured. Any tissue gets injured, inflammation is the very first step in the healing process. And whenever you injure a tissue, you want to fix it, you need inflammation. So inflammation kind of gets a bad rap. We think about like chronic inflammation, and that's bad. But in the normal focus of the immune system and the healing process, inflammation is good. Now, remember, we have areolar connective tissue under every epithelium. Well, think about your skin, for example. Your skin has an epithelial surface, the epidermis, right? You damage your skin. It makes sense that the tissue underneath it has these immune cells. Think about the epithelium lining your trachea. Lining your esophagus. You can damage that. It makes sense that you've got immune cells in the tissue underlying that epithelium. All right, so if you see a granular cell like so amidst all the fibers, you are going to know what is a mast cell. And by the way, the word mast has nothing to do with like the mast of a ship or anything like that. It comes from a German word meaning food, because somebody originally thought, hey, maybe these are little food bags inside this cell. All right. Now I got a picture for you. I want you to pause this if you need to. Find all that stuff that I listed right there. And then keep on going and join me as we continue. All right. Connective tissue number 2. Adipose tissue. Adipose tissue is fat tissue, okay? It is a weird connective tissue. And what makes it weird is that it is going to break one of the rules I just established a moment ago. I just told you that connective tissues, you got fewer cells and more matrix. Adipose tissue breaks that rule. Adipose tissue is dominated by cells. It is primarily composed of cells. And the cells are called adipocytes. I'm going to put some dots in my adipocytes. They look kind of empty. These are all adipocytes. Lots of adipocytes. Adipocytes are fat cells. There is only a meager, a scant amount of extracellular matrix in adipose tissue. So it's like the exceptional connective tissue in that regard. So this is an adipocyte right here. Here's one right here. They look empty. They're not actually empty though. They look empty because they have this space in them. And the space was there to store fat, to store lipid. In an actual adipocyte, there would be this big oily droplet of lipid in here. So it would be just filled up with this big oily droplet. And when they make the slide, to look at it under the microscope, the oiliness gets washed away, so the cells appear empty. All right. One interesting thing is, as you look at these guys, you may wonder, all right, they look empty, but where's their stuff? Where's the nucleus? Now, in some of these guys, it's really hard to see the nucleus. It's like almost impossible to see the nucleus. And in a couple of them, I can make the nucleus out, though. The nucleus in an adipocyte is pushed off to the side. It is in what is called an eccentric position. Eccentric means away from the center. The fat droplet actually pushes the nucleus off to the side. So I might see the nucleus tucked to the side, or depending on my view, the angle I have, I might not see the nucleus at all. Okay. Obviously, the adipocytes, they're storing fat, so they are storing energy. But that's not it. There's more to it. We have subcutaneous fat in other words, fat under our skin, in our hypodermis, we have it there because it provides thermal insulation. In other words, it stops heat from leaving your body. Less subcutaneous fat you have, the easier it is for heat to leave your body, the colder you will get. We also have fat surrounding a lot of organs. We have fat around our hearts, around our kidneys. We have fat, a good deal of fat in our eye sockets as well. And this is the fat there is there for shock absorption. Okay, I think I am done with talking about adipose tissue, and I got another picture here. I want you to find all of these things, pause it, touch it on your screen, take a screenshot, and then label it. Yeah, that's a good idea. Good study technique right there. So, folks, we have done 2 of the 4 connective tissues in today's lab. We've got 2 more to do. The next one we got here is this one called dense regular connective tissue. Now, first off, I want you to notice purple ovally things. Those are nuclei, those are cells, and those are fibroblasts. So again, we have fibroblasts. And then, look at all of the pinkish vertical lines. If we think back a moment ago to areolar connective tissue, what fiber was colored pink? It was collagen. So there is a ton of collagen in dense regular connective tissue. In fact, the word dense in this tissue, the word dense refers to the abundance of collagen. The word regular refers to the fact that the collagen is oriented all in the same direction. It's all going up down here. This makes this tissue really strong, especially in this particular direction. Now we find this tissue in our tendons. We find it in our tendons. And we also find it in our ligaments. That's some bad cursive writing right there. Ligaments and tendons. Let me refresh your memory if you didn't remember this or don't know this. Tendons anchor muscle to bone. Ligaments anchor bone to bone. These are two areas where we can put a tremendous amount of stress on the body. So we need these tissues to be tremendously strong, to have high tensile strength, and we get that by doing a 2-move approach. We have a lot of collagen, and we put it all in the same direction, so we're super duper strong in that direction. Now you're probably wondering, hey, Professor Imholtz, how come people tear their ACL? How come people tear their ligaments and tendons and stuff like that? Well, think about it for a second. This tissue is super strong in that direction of those fibers, right? They're all oriented the same way. They're really strong in that direction. And I bet the light bulb just went off in your head and you got the answer now. If we stress this tissue in another direction, like if you bend that ankle, that knee in the wrong way, now you're stressing this tissue in another direction, the direction in which the fibers are not oriented, and snap, it breaks. Okay, wonderful. Let's look at another picture. Hey, I got another picture of dense regular connective tissue. Find the 2 things here. Probably don't even have to pause it. And by the way, on your lab exam, I will show you pictures of these tissues, asking you to name the tissue, name the parts, to tell me where in the body these tissues are found. So that's all fair and good for lab exams. Okay, 3/4 of the way done, 75% done with the tissues for today. We got one more to do, last but not least. It is dense, irregular connective tissue. Maybe you saw this coming. We have dense, regular, so we also are going to have dense, irregular. So the common word there was dense. Both these tissues are dense. They're both abundant in collagen. And again, I see a lot of pink here, right? I see all this pinkness, I also see the fibroblasts, the fiber makers that make that collagen. Now, the irregular refers to the fact that the tissue, the collagen fibers in the tissue is disorganized. It is pointing in many, many different directions. So in dense regular, collagen in one direction, dense irregular, collagen in many directions. Now, this makes us strong in a lot of directions, not as strong as the tendons were in that one direction, but we're really quite strong in many. Now, this tissue is abundant in the lower layer of your dermis, the reticular dermis of your skin. You also find it around your like your joint capsules, the capsule around your shoulder joint, elbow joint, and in other places in the body as well. Okay. Here I've got some dense irregular connective tissue. You should be able to find me a whole bunch of fibroblasts and a whole good amount of collagen fibers. And then real quick, I wanted to show you dense, irregular, and some other stuff as a part of skin. This is some thin skin here. I got some epidermis right there. Just for fun, what's this bottom layer right here? It's the stratum basale. What's this one right here? Stratum spinosum. This guy right here, stratum granulosum. And then last but not least in this thin skin, I got the stratum corneum. Then down here, I got my dermis with my papillary dermis, which is mostly areolar connective tissue. Then my reticular dermis, which is dense irregular. Notice the abundant swirly collagen fibers. And I can see some cute little fibroblasts in there too. And here I got two more views just for your viewing pleasure, where we can see the dermis, we can see the papillary and the reticular layer. I kind of like this one on the right better than the one on the left. I don't know about you. But yeah. And folks, with that, we are absolutely done with the lab number 5 video. Hooray. Fantastic. I'll see you guys when we finish connective tissue for the lab number 6 video. Until then, study hard, take it easy. Bye-bye.